Today, I want to focus on writing equation for sinusoidal functions. The equation of a sinusoidal function can be written as y equals a times sine or cosine k times x minus d plus c, where a and k are determined by the amplitude and the period. D and c are determined by the horizontal shift and the vertical shift. Let's see. The amplitude A absolute value equals maximum minus minimum divided by 2. So equals 3 minus -1 divided by 2 equals 2. The vertical shift C equals maximum plus minimum divided by 2. So 3 plus -1 divided by 2. So equals 1. So you see the midline is y equals 1. Now the period is peak to peak, which is from 0 to 10. So it's 10 equals period. And we know it equals 2 pi over k. So we get k equals 2 pi over 10, which is pi over 5. Now let's look at phase shift. It starts from the maximum and go down. So it has same pattern as cosine. If we use cosine, then there's no phase shift and A is positive. So the equation can be written as y equals a 2 cosine k pi over 5. X minus d is 0, so just x plus a equals 1. If we use sine, we know sine starts from midline and go up, so it should be here. But in that case, we need to do a phase shift from 0 to here acts like 3/4 of a period. 1/4, 2/4, 3/4. So D equals 3/4 of 1 period, which is 7.5. So you see, the equation can also be written as y equals 2 sine k pi over 5 x minus 7.5 plus a, which is 1. We can also use degrees. We know 360 degrees equals 2 pi. So we see 360 over k equals period, which is 10. So k equals 360 divided by 10 equals 36. So the first equation can be written as y equals 2 cosine, now k becomes 36x degree plus 1, or y equals 2 sine k 36 x minus 7.5, again degree plus 1. Let's look at next example. The amplitude A equals maximum, which is 2, minus minimum, which is -4 over 2. So we get 3. The vertical shift, say, equals maximum plus minimum divided by 2. So we get -1. So you see the midline is y equals -1. Now look at the period. It starts from midline, go up, go down, and then go down to minimum, and then go up. That would be a full circle. So you see the period equals pi, but we know pi equals 2 pi over k. So k equals 2 pi over pi, which is 2. Now let's look at the phase shift. It starts from midline and go up. It has the same pattern as sine. So if we use sine, there's no phase shift and A is positive. So we know the equation y equals A, 3 sine k, which is 2 x minus d 0. So plus c, which is -1. If we use cosine, then you know the maximums here and go down. In this way, it has the same pattern with cosine, but we need a horizontal shift. So from here to here, you see here is a half pi, so that should be pi over 4. So d equals pi over 4. So the equation can be written as y equals a, which is 3 cosine k, 2 x minus d pi over 4 plus a minus 1. Finally, let's look at the last example. For this one, the amplitude equals maximum 5 minus minimum -1 over 2, so equals 3. The vertical shift, say, equals maximum plus minimum divided by 2, so it equals 2. So you see the midline is actually y equals 2. The period is from peak to peak. Here's 3 pi, here's 7 pi. So 7 pi minus 3 pi equals 4 pi. We know the formula equals 2 pi over k. So k equals 2 pi over 4 pi, which is half. Now let's look at the phase shift. It starts from midline and go down. But we know sine is start from midline but go up. So you see there's a refraction. So if we use sine, then there's no phase shift, but we have a refraction that corresponding to -a. So we know the equation will be y equals 3 but negative sine k, which is half x minus 0, plus a plus 2. If we use cosine, then the maximums here and go down. So it has same pattern as cosine, but we need to do a horizontal shift from 0 to 3 pi. So d equals 3 pi, and the equation can be written as y equals a, 3 cosine k half x minus d, 3 pi plus c, 2. That's all for the video.